You know that feeling, right? You're using an AI to help you code, and 1 minute, you're just in awe. It spits out this perfect, complex algorithm like it's nothing, but the very next minute, it can't figure out a simple import statement. It's like it's a genius and an intern, all at the same time. So today, we're going to get to the bottom of this. We're going to dive into why this happens and what it really means for how we're going to build software in the future.
I mean, this is the big dream, isn't it? For every single developer, every startup founder, every solopreneur out there. Imagine this. You write one single, detailed prompt, and poof, out comes a fully functional, ready-to-go application. That's the promise. But how close are we really to that? Is it just a fantasy?
Okay, so let's start with the genius part. Because at the micro level, at the function level, the AI is an absolute genius. Seriously, you give it a small, really well-defined task, Something like, hey, write me a function to sort this list, or query this database, and boom, it just nails it. We're talking incredible accuracy here. Some of the latest research shows it's right up to 95% of the time. When it comes to these little isolated puzzles, it is just brilliant.
But, and this is the big but, the second you ask it to zoom out, to think about the entire project, the whole code base, that amazing success rate just falls off a cliff. I mean, we are talking a drop to under 30%. All of a sudden, our certified genius is acting like a brand new intern on their first day who has absolutely no clue how all the different pieces are supposed to fit together. This is the great divide we're going to unpack.
All right, section 1, the reality check. Let's really dig into this big gap. So why? Why does the genius suddenly turn into the intern? Well, the answers are actually coming from some of the most fascinating research happening in computer science right now.
And look, this isn't just a hunch that developers have. This quote right here gets straight to the heart of the problem. It's from a recent workshop with some of the top minds in AI for code, and they found that while these models are great at the function level, their success just plummets when they need repository-level understanding. And that's the key phrase right there, repository-level understanding. It's the ability to see the whole chessboard, the entire project, not just one single piece.
So where does this all start to go wrong? Where's the first domino to fall? Well, it turns out it's right at the very beginning, with a step that is so fundamental that most experienced developers, we just do it on autopilot without even thinking about it.
Environment setup. Yep, that's it. The boring but absolutely critical first step, just getting the project to run. Installing the right dependencies, configuring the build systems, setting up all the paths. To a human, it's a chore. To an AI, it's a total nightmare. It's the exact equivalent of that new intern who spends their entire first day just trying and failing to get the right software installed on their computer.
And don't just take my word for it. Look at the scale of this problem. This data is from a brand new benchmark from JetBrains called EnvBench. Just look at that bar for Python projects. The success rate for just setting up the environment, it was a jaw-dropping 6.69%. Let that sink in. That means the AI fails at the very first hurdle more than 93% of the time. It's just not getting out of the starting gate.
And this problem goes way beyond just setup. It applies to any complex systems-level task. So on the left, you've got your simple function, no sweat. But on the right, that's a task from a Stanford benchmark, where they ask the AI to write a high-performance GPU kernel. Now what's that? It's a tiny, hyper-optimized piece of code that talks directly to the graphics card. It's about as low-level and specialized as you can get. And the result? The very best models only succeeded on the easiest of these tasks about 12% of the time. The moment it needs to understand the whole system, the genius just gets lost.
Okay, next section, unsolved repository puzzles. Because the problems really start to pile up from here. It's not just about getting started. The entire project, the whole repository, is just littered with these little traps and puzzles that today's AI coders, they just can't solve them alone.
I mean, look at this breakdown. The problem has so many different faces. First, security. A study from ETH Zurich found that a staggering 62% of the code the AI generated for backend tasks was either just plain wrong or had huge security flaws. Then, what about changing things? Ask an AI to modify existing code to add a new feature, and it fails almost 90% of the time. And maybe the sneakiest problem of all is global consistency. The AI will make a change in one file that looks perfectly fine on its own, but it ends up causing a chain reaction of errors that breaks the entire project.
Okay, so that's a lot of bad news. But here's the pivot. The really exciting part is that researchers aren't just sitting around pointing out the problems. No, they're coming up with some seriously clever and creative strategies to actually solve them.
And here's the big insight, the real breakthrough idea.
The solution isn't just to throw more data at it and build a bigger, more powerful model. That's not it. The real future is in building smarter systems. Systems that use these powerful models as just one part of a bigger machine. A machine that can guide the AI, put guardrails on it, and double-check its work.
So, strategy number 1. Build an AI software team. Instead of thinking of the AI as a single, lonely coder, you think of it as a whole team. You build specialized agents for each role. You've got your reader agent that just analyzes the problem. Then the planner agent comes in and creates the strategy. The developer agent, well, it rates the code. And then crucially, you have a reviewer agent that acts like a senior dev, checking all the work. There's a system called AutoKaggle that used this exact approach and hit an 85% success rate on really tough data science competitions. It just works.
Okay, this next one is it's so clever. Check this out. Researchers found that if you ask an AI to translate code directly from one language to another, let's say C++ to Rust, it often messes up. But they figured out you can take a detour. It's like, instead of going straight there, you translate the C++ to Python first, which the AI is great at, and then you translate that Python code into Rust. Each little hop is easier for the AI, and the final result is way, way more accurate. It's like finding a clever little back road when the main highway is closed. Strategy 3 is all about enforcing the rules, basically adding some adult supervision. Instead of just letting the AI generate whatever it wants, you hook it directly into the language's compiler. Now, just by forcing the AI to generate code that looks right, has the right syntax, you already cut down errors by about 9%. But here's the kicker. When you force it to generate code that is logically correct, that follows the language's deep grammar rules, making sure a number is always treated like a number, compilation errors drop by an incredible 75%. That is a huge leap. And I just want to give a quick shout out to who's doing this amazing work, because it's happening at the absolute top labs in the world. You've got Stanford pushing the boundaries on that really complex systems level code. You've got JetBrains who are tackling that brutal environment setup problem head on. ETH Zurich is leading the way on making this stuff secure and correct. It really is a massive effort from both universities and the biggest names. All right, our last section, the Solopreneur's AI Playbook. So let's bring this all home. We've talked about the problems, we've talked about the cutting-edge solutions, but what does all this mean for you? For the developer, for the solopreneur just trying to build things and get work done right now? So here's how you should think about using AI coders today. It's really simple. Treat your AI like that brilliant but clueless intern. You are the architect. You are the project lead. The AI is the intern you give small, very clearly defined tasks to. So use it for functions, not for entire systems. You have to be the security reviewer, always checking for flaws. And when you use it to translate or refactor code, you still have to run the tests. The bottom line is this: let the AI accelerate your work, but never, ever let it replace your own judgment. So, when you pull it all together, the biggest takeaway from all this incredible research is this: the next revolution in AI for code isn't going to be just a bigger model. It's going to be a smarter system built around the model. A system with different agents, with rules, with checks and balances. And that leaves me with one final question for you to think about. As you go back to your own work, to your own projects, what's the first piece of your smarter system that you're going to build?